So now, here we have the 78L05. So the larger version is the 7805. It may have letters in front of it. They don't really matter very much. The 78 stands for the positive voltage regulator. It's going to regulate a voltage across the load here. And the 05 indicates that it's 5 volts, that it's going to regulate there. And so we should have 5 volts across the load. This is only a 150 ohm resistor. We expect about 20 milliamps of current, which you see there. You need the supply voltage to be at least a couple volts higher. It always takes away some of the supply voltage. But now it's taken away a lot more supply voltage. I think 20 volts is kind of the limit I want to push for how hot I want to get this component to be. So all that extra voltage is just turning into waste heat right there. And I believe a data sheet only showed one capacitor, so I added one there in between the input and ground. Front side's facing away from us, output is at the bottom. So now, here's the schematic diagram that inspired me to make this video. I made it a long time ago, and for whatever reason, I added the 150, but that gives us 20 milliamps of current. Because this is a voltage regulator, it's going to maintain 5 volts across the load. You give it a higher voltage from the supply though, and realize we're looking at the back of it right now. Make sure you put it in the right way. And the data sheet must have only showed one capacitor. It looks like it showed 0.22 microfarad, but I got about half of a microfarad, 0.47 right there. So it says 78L05. L is the smaller version of the 7800 series, which is in the TO220 package, larger than this with the heat tab. So the L in the middle. Now the middle pin is ground right there. So that's where the voltage difference comes. If you set this to a voltage, maybe you set that to 5 volts, then in relationship to 0 volts, this would be 10 volts coming out. You can do that as well. But here we got 0 volts, so 5 volts coming out, going across this load right there. And I was getting higher than 20 milliamps of current previously, but in my demonstration, it looks like we got 20 milliamps. So 150 ohms across that load right there. We should expect about 20 milliamps of current. And so yeah, you saw when we went up to 20 volts, it was still about 20 milliamps of current flowing. All that extra voltage will just turn into waste heat, and the component that gets hot when it comes to that extra voltage is the voltage regulator. So I think 20 volts was the limit I set for this component to make sure it doesn't get too hot, although it can handle higher voltages at lower currents. And so just be aware of that. But yeah, here's the front right there. As I said before, out is to the left, and then ground is in the middle. Input is to the right, but of course on the board here it's opposite because I have it in backwards right there. So just be aware of that. So I figure we would grab the multimeter and actually look at the voltages involved, and maybe measure the actual current right there, especially if we don't see the voltages that we want to see. So again, so power is off right now, and so when I was showing the schematic, power was off. I'll try to remember to add a note at the bottom of the screen that the power was off. That's why the LED was off. But yeah, we should have about 10 volts right there. We're going to lose a little bit, especially with this cheap breadboard, because of all the connections. And there we go, pretty spot on, 5 volts at the output. And okay, it's just settling right there for whatever reason. So again, this is a cheap board. Connections kind of come loose, so that's something to be aware of. Now, before we measure the current, I'm trying to decide how to do this because this resistor is going to be hot. So what I'm going to do is, well, I can turn the power off, of course, and resistor is probably hot, so let's pluck it out and then set it over here, right there. So we have to pass the current through the meter. That's the main thing right there. And again, use a 220 ohm resistor. That will work much better. Now, we have an opening in the circuit, and I don't want to leave it on measuring current longer than I have to, because if I went to measure a voltage, it would accidentally put too much current through there, and I could blow a fuse. Something to be aware of. And it's kind of a pain. I think I blew the high current fuse on this and haven't got around to replacing it. So if we put it backwards, we'll get a negative voltage or negative current. That's right, I turned the power supply off. Alright, power supply is on now, and so this should light up when I'm off the roll. The resistor had time to cool down by now. I was off the roll that the LED was in. Something to be aware of if you know, it's not measuring. So yeah, we're under 20 milliamps of current. So I wanted to make sure because in things, current tends to go up a little bit as things warm up. So that's not too big of a surprise. But it will level off at some point. But we're close enough, 20 milliamps. Again, normally I use a higher value resistor, 220. 20 milliamps is the maximum for those LEDs. Try to stay lower. But yeah, it worked out pretty well. Earlier, I was just looking at the power supply for how much current was flowing, but it's usually off, you know, like 1 or 2 milliamps of current. This is 1 milliamp right there. And so that's going through the component, the voltage regulator right there. It draws a little bit of current. So whether it's 10 volts, remember there's no load right now. But yeah, we went 20 volts. So that needed a little bit more current. None of it's going through the LED. That's all the voltage regulator that you see there. And it's not as accurate as a multimeter. So be aware of that. Something to think of when you are just looking at the current being provided by the power supply. It's a 5-volt regulator, but you got to have a couple volts higher. So in any case, not that complex, but it's kind of a long video. So hope you enjoyed. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen. And check out links down below. They all help out a lot. I'll see you in the next video.